This is Numbers with Nicole. Today we're going to talk about sine and cosine of complementary angles. So the sine of A equals the cosine of B if and only if angle A plus angle B equals 90. This is what we're going to be talking about today. So in a right triangle, this relationship is true when angle A plus angle B are complementary. So we're going to use this right triangle that's below with a right angle at C. So are angle A and angle B acute angles? Yes, they both measure less than 90. So that's what acute means. And why do we know that? All right, well, let's figure out why we know that. So we know that all three angles in the triangle, angle A plus angle B plus angle C, has to equal 180. We know that angle C is a 90-degree angle based on the little square. So if we move that to the other side, we are left with angle A plus angle B equals 90 degrees. Now, in order for this to be a triangle and have three angles, each of those angles must be less than 90, but greater than 0. So therefore, they are both acute angles. So now we want to rewrite angle A in terms of angle B. We could do this for angle B as well. So since I want angle A by itself, we would subtract angle B from both sides. So angle A in terms of angle B would be 90 degrees minus whatever angle B is. All right, so how does this relate back to trigonometry? Let's look. All right, so let's say we have the sine of A. So I know that sine is so. We'll compare the opposite over the hypotenuse. So if I look at angle A as my reference angle, BC, the opposite, would be 4, and our hypotenuse AB would be 5. O over H, 4 over 5. Now they want to know what is the cosine of angle B, where B would now be our reference angle. So angle B, or cosine, compares the adjacent over the hypotenuse, ca. So our hypotenuse of 5 will still be the same. And now the adjacent side, or the side next to angle B, is 4, or BC. So if you notice, sine of A is equal to the cosine of B, because when we change that reference angle, the opposite side becomes the adjacent side becomes the opposite side. They don't change when we change our reference angle, right? Hypotenuse is hypotenuse. So we can go the other way as well. If we look at the cosine of A, we know that is adjacent over hypotenuse, so that would be 3 over 5. And since sine of B, well, that adjacent side would become opposite when we switch to angle B, so we know it's going to be the same, 3 over 5, since angle A plus angle B equals 90. Now, is this true for all right triangles? Yes, this is true for all right triangles. So we look down here at this example. If I look at angle A, sine would be opposite over the hypotenuse, the ratio. So that would be 2 over radical 13. And if I look at the cosine of the angle B, right now I'm looking at angle B, if I look at the cosine of that, that would be 2 over radical 13. So again, we expect these two values to match. So now if I go back to angle A and I look at the cosine for angle A, that would be 3 over radical 13. And if I do the sine of B, again, these should be equal to one another. That's going to be 3 over radical 13. Again, the adjacent and the opposite side will switch when I switch my reference angle.